The next level that we will look at is level 12, and it is about nitrogen and sulfur, but it's actually more about nitrogen than sulfur. So you will learn quite a lot of stuff about nitrogen and how awesome it actually is. There's a lot of properties of nitrogen that we can use to our benefit, but there is also stuff with nitrogen that is a pollutant, and it makes the sky very like dirty, and it's not good for us. So there's like the upside and the downside, which is quite interesting, and we will look a bit into both sides of that. So first of all, you have to realize that nitrogen gas, so the N2, is actually very unreactive, and they love asking why or explain why nitrogen is unreactive. And the reason for that is actually twofold. So the first reason is that it has a very strong triple bond, and you will see there I drew the picture of nitrogen gas, and the triple bond is the strongest type of bond that we get. So remember we said that a double bond is stronger than a single bond, and a triple bond is stronger than a double bond. So because that bond is so strong, it needs a lot of energy to break the bond, and therefore nitrogen is very unreactive. So the activation energy of nitrogen is very high in response to that. Then another reason why nitrogen is unreactive is because it has absolutely no polarity. Now, if you go back to the level that we did about electronegativity, then you will remember that we get polar and non-polar molecules, and nitrogen is an example of a non-polar molecule. And whenever a molecule is non-polar, then the electrons are distributed evenly across the molecule, which means that there's no like instability in the electron cloud. And remember I said for chemistry everything wants to be stable. So if nitrogen already is stable, why would it want to react? So that is why the lack of polarity means that the nitrogen molecule is unreactive. Then just another thing that you just need to like refresh your mind on is that we get a very common compound called ammonia, NH3, and this ammonia is we can make it in the laboratory, and it's very like commonly used to in fertilizers. So you have to know that ammonia reacts as a base. So in other words, it accepts a proton, and when it accepts a proton, it forms the ammonium ion. You will see I wrote the equation there. So just know that you can turn ammonia into the ammonium ion by reacting ammonia with with an acid. So then you actually have an acid-base reaction to form ammonium salt, which can be used as a fertilizer